And now we move into Unit 3, which is our most current material. The first question here deals with finding the sum of the interior angles of a polygon. Now notice down at the bottom, I have included all of the formulas from the notes. So you have the sum of interior angles, right, is denoted as S is equal to the number of sides minus 2, because that means that there are that many triangles in the interior. So if you look at the number of sides here for problem A, what's the number of sides? You got 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. So that leaves us with the sum is equal to 6 minus 2, which is 1, 2, 3, 4 triangles, times the sum of a triangle, which is 4 times 180. And that value is the answer for A. And the same process you're going to follow for B. But as we progress through the rest of these formulas down at the bottom here, then you have the interior angle, right? The interior angle, a single angle of a regular polygon. So if you take the sum, right, S, that would be this whole thing here, right, and divide that by the number of sides, you would get the value of one angle. So if this were a regular hexagon right here, you would take the number, that sum, whatever that answer is, divide by 6, and that would give you the value of 1 interior angle inside that hexagon. But this isn't a regular polygon, so we didn't go there for that question. Then you have the sum of all exterior angles of any polygon is simply just 360. If you have a regular polygon where all the angles and sides are the same, and you want to know the measure of one exterior angle, well then just take 360 divided by the number of sides. And of course, if you want the number of sides of a regular polygon, you take 360 and you divide it by one of the exterior angles, and you would get the number of sides. All right, let's move on. For number 3, it says find the measure of each exterior angle of a regular polygon with 6 sides. So that would be your each angle for exterior angles formula from the previous slide. So go back and grab that formula and work that one through. And that answer is not a decimal, comes out nice and clean. Now for number 4 here, we take a look over here, and again, we're going to need to know the value of n. So you got 1, 2, 3, 4, 5. So this is a pentagon, right? And all of the information here, right? You have 5 pieces of information that relate to angles. So I know that if I add all of those angle pieces, right? So first, second, third, fourth, and fifth angle information, it should be equal to the sum of the interior angles of a pentagon. And that is that n minus 2 times 180 formula, right? So that's going to give you your sum. That sum is what I add all of these angles and set equal to. Solve for x, and that's that. The next set of questions runs a little bit like this. Some angle measures are given on the polygons below. Which of the figures are possible and which are impossible? If impossible, explain why. So really what I notice here is that we have ourselves a triangle. And I know that that's 103 degrees. And I know that that's what a triangle is supposed to add up to be. The interior angle should be 180. And so what I do is I come over here and I say, well, I see a linear pair right here. So if this is 100, then this has to be 80, because 180 minus 100 is 80. Okay, so now I have a 103 degree angle and an 80 degree angle. And if you add 103 plus 80, I get 183, which is not possible. So I'm going to say, no, this is not possible. Why not? Interior sum does not equal 180 degrees. Now over here, I see that this is a quadrilateral. It's kind of a crummy arrow. Well, there we go. Now that's an arrow. Now when I look at this quadrilateral here, I see that I have 4 interior angles. And what I need to know is, what is the sum supposed to be for a quadrilateral? Now you either know that number or you can process again that n minus 2 times 180 and decide for yourself if that works out. If it does, circle yes. If it doesn't, circle no, and describe how the sum may not equal a certain number. But again, that's only if it's a no. And hopefully you're getting the hang of things. So now we're back to a triangle down here at the bottom. So we got those three angles. Does that work out? Yes or no? And then right here, you're going to want to calculate the value of n. So side 1, 2, 3, and so on and so forth as you go around. Identify the figure, identify its sum, and then figure out if 130 should be one single angle, or decide if 130, as many times as it shows up, adds up to what the sum is. And then choose yes or no for your final answer, and y if it's a no. And that's that. And as we cruise into the most recent information, the big thing is happening right here. So what do we got? We got that all of this stuff is our parallelogram information. And then this was the additional stuff that's true for a rectangle on top of the parallelogram information. Right here was the stuff that was true for a rhombus, right, plus the parallelogram information. And then all of it was true for a square. And we're going to use that information to answer these questions that are upon us. So we take a look, and for numbers 6 through 9, we're going to assume that they're all parallelograms. I have 15x minus 19 and 11x minus 3. This has to do with segments, right? You always have to decide, are these segment questions or angle questions? These are segments, so what do you know about opposite sides? I know opposite sides are congruent, opposite sides are parallel. What other segment stuff is in here? Diagonals bisect each other. Well, these aren't diagonals, they're opposite sides, and opposite sides are congruent. So I'm going to use 15x minus 19, set that equal to 11x minus 3. And I'm going to solve for x, and I'll have that part. And then it says that it wants the length of AD for a final answer. So I suppose I'm going to substitute x in for there, and I'll get my AD answer. Moving on over to EH. I should say number 7, rather. And let's see, it says that EH, I know some information about that. And HG, I know some information about that. And I know that these happen to be diagonals, and diagonals bisect each other, so I guess that makes that, you guessed it, congruent. Down for number 8, these angles right here are alternate interior angles of parallel sides. How do I know? Because opposite sides are parallel in a parallelogram, and so if these are alternate interior angles, that makes them congruent. For number 9, these are consecutive interior angles, and consecutive interior angles, according to our information up here, right, is the fact that they are supplementary, which means they add up to 180. And so there's a little heads up on how to deal with all those. But more importantly, notice how I keep referencing what I know about the figures, right? I identify whether it's an angle or a side piece of information, and then I go to the definitions about the shapes. On this last portion, remember, a square has all the properties of a parallelogram, rectangle, and a rhombus. So number 13 is a square, and I know that this angle right here is 90 degrees, and I know that the diagonals bisect opposite angles. So if I bisected it, then these two angles right here are half of 90, or 45 degrees. So 7x plus 3 must be equal to 45 degrees. And I'm going to solve for x like that. For number 12, this shape is a rhombus. So I know that I have all this information, and all this information is true about a rhombus. And it looks like everything here deals with angles. So we got a lot of angle stuff going on. They give you one given angle, but I know that these guys are the same. So I should be able to get the big angle here. Once I get that big angle, I know that that's consecutive interior to this big angle here. Once I have the big angle here, I know that these guys right here, 1 and 2, are half of that. I know what 80 is based on the fact that diagonals are perpendicular, so I know a lot of stuff going on there. As I move backwards up into the two rectangle questions, I know that my rectangle information is right here. Of course, all the stuff that's true about parallelograms is also true. So I see that this is 16. Keep in mind, if the diagonals bisect each other, I'm going to have an isosceles triangle right here. So whatever angle this one right here is the same, and so is this one and this one. And then I have these two are the same as these two, because those are also congruent isosceles triangles. And I know that the corner here is 90. In fact, all the corners are 90. So if I know the little guy right here is 16, then I should be able to get this one right here by subtracting from 90. And should be able to put away all of these angles with no problem. And over here, they're asking me to find dB. dB is the length of the whole diagonal. And what did they give me in turn? At first, they gave me AE. They gave me this little piece right here. They also gave me EC. EC is this little piece right here. And because diagonals bisect each other, I know that these guys are congruent. So I can set them equal to each other and solve for x. Once I know x, I can get the length of AE and EC. And therefore, I'll have the length from A all the way to C. If I know the length all the way from A to C, I know the length from D to B because the diagonals are congruent. And that about wraps us up for the whole entire midterm review. Hopefully these videos were helpful in pointing you in the right direction. See you at the midterm.